Hey class, this is Gigi. I'm going over written assignment number 16. This is question number 1, part A. And our job here is to find the radius of convergence and the interval of convergence for the series here. Okay, so if we actually look at what it means to find, as far as the radius of convergence and interval of convergence mean, right? We're talking about a series, and this series, when we look for the ratio test and the root test, which is what we do to find the radius and interval of convergence, it is going to depend on the value x. And so in this case, the center is in the center. So the power series is of the form some coefficient multiplied by a minus x minus a to the k power, right? That's the power series. And we would say power series of this form is centered at point A. Okay, so in this case, your A is 10, right? So your A is 10 in this case. So the center here is 10. The question is asking you, how far away can x be from 10 and your series will still converge? So that would be your radius of convergence is blank. That's what we're looking for. And then with that radius of convergence, you could go to the left or you could go to the right. So then from here to here is how you would describe your interval of convergence. And when looking at interval of convergence, you want to know, am I going to include or not include the endpoints? Okay, so that's conceptually what we are doing. In order to go and find out what the radius or interval of convergence is, we need to apply either the ratio test or the root test. So in this problem, the ratio test seems appropriate here for this. Okay, so that's what I am using. And the ratio test said take the limit as k goes to infinity of the absolute value of k, a sub k plus 1 divided by a sub k. Okay, and we are going to be looking at limit as k goes to infinity of absolute value of k plus 1 factorial times x minus 10 to the k plus 1 divided by k factorial times x minus 10 to the k power. Okay, so when looking at this here, we would say when we simplify the factorial, k goes to infinity. When we simplify the factorial, the k factorial will cancel with the k factorial. You will be left with just k plus 1. And we don't need to write the absolute value there because k is a number from 0 to infinity, which is positive. So k plus 1 is positive. The absolute value of that would be just itself. Whereas when we cancel out x minus 10 to the k power, or with what we have on the numerator, there's one more copy on top. So there is one copy left when we divide the x minus 10 to the k power out. However, we need the absolute value here because we don't know where x might be. The value of x minus 10 might be a negative number. So we have to go ahead and write absolute value right there. Okay, so this is what we mean by the limit is depending on the x value, right? And so that's why we are looking for the radius of convergence, meaning what x value away from 10 can we use in order for this series to still converge. So in order for this to converge, we need this limit to be less than 1. Okay, So it needs to be less than 1 to converge. So let's go and find out what this limit is. So when k goes infinity, you would have k plus 1 being a really big number, multiplied by absolute value of x minus 10. Well, whatever x minus 10 is, multiplied by a really large number will be a large number except for maybe at x equals 10. Because then you would have 0 multiplied by some number will give you 0. So this value here, this value L, is a big number except for at x equals 10. Okay, so if x is equal to 10, then that limit is 0, which is less than 1. So your series will converge. But otherwise, your series will diverge, right? So, except for x equal to 10, then the limit is going to be 0, which is less than 1. So that converges at 10. Or if we really want to think about this right here, we will write out the series when x is equal to 10. Okay, so when x is equal to 10, what you will have as far as your series go, your series will be 0 to infinity of k factorial times 0 to the k, right? So when k is 0, you have 0 factorial multiplied by 0 to the 0 power, plus when k is 1, you have 1 factorial multiplied by 0 to the first power, plus 2 factorial multiplied by 0 to the second power, and so on. Okay, if we look at this, 0 to the second power is 0 times whatever is 0. This right here is going to be 0. And then what is this right here? Okay, so by definition, 0 factorial is 1. This right here is a questionable one. 0 to the 0 power, by definition, will either go into be an indeterminate form or it is 1. Usually in the context of power series or combinatorics, we would say 0 to the 0 power is being defined at 1 because it is more useful then, right? So it really is depend. And if you're looking at a limit, when you were working on limit, 0 to the 0 power, we say is the indeterminate form. So there's what is 0 to the 0 power? It depends on the context. And in this case, we'll define 0 to the 0 power to be 1. So that our series actually converges to 1. Okay, so our series converges to 1 because our series is just 1 plus a bunch of 0. So our series converges to 1 when x is equal to 10. Okay, so in other words, your series will diverge everywhere. Okay, so nothing here, nothing here. The only place that your series will converge is 10. Radius of conversion is 0. You're not stepping away from 10. And interval of conversion will just be the number 10. And not any interval, really. It's just a number at 10. Okay, so that is question 1A.